Hey, you've probably heard about Web 3.0, but you know enough about it that you could explain it to your executive team? Well, stick around, and after the end of this session, you will know. Well, hello, and welcome to another episode of CISO Tradecraft, the podcast that provides you with the information, knowledge, and wisdom to be a more effective cybersecurity leader. My name is G. Mark Hardy. I'm your host for today, and I have a special guest here, Aaron Markell, who we're going to be talking about Web 3.0, the business cases for it, kind of the underlying of how it works, and essentially trying to make you understand this technology well enough that you could address business questions that take place in your organization should they come up, instead of just sort of either staring like a deer in the headlights or saying, well, boss, let me get back to you. So without any further ado, Aaron, welcome to the show.
Thanks for having me, G-Mark. Appreciate it.
Well, I had a chance to meet you at some events here in the Tampa St. Pete's area, and we got to talking, and I realized that, man, you are an expert in this area about Web 3.0. Now, I have dabbled around on blockchain, and I think I was an early adopter in and an early adopter out when I looked at it and said, back around 2012, the only business case I could see was, well, facilitating crime. Of course, it has done a little bit differently. If I wished I'd held on to my Bitcoin, because at 100,000, they're worth a whole lot more than I think where I unloaded them at 600 or 700. I even put on my taxes way back then. I made a couple $100 on Bitcoin. But nonetheless, tell us a little bit about your journey and how did you get to the point where now you're an expert in Web 3.0?
Yeah, I get to a point in my life where I really hesitate to call myself an expert. I kind of shudder when I see that on LinkedIn profiles and such, but I call myself just enough to be dangerous, where I can have conversations like with like-minded souls like yourself. So at this point in my life, I've been in security for pretty much all of it, minus the early years, of course. So 25 to 30 years, give or take. Like yourself, I was proud to serve in the U.S. military. So that's where I got my start. So I've been doing some form of security or cyber since, I guess, before it was cool. So I worked in, Web 1 companies, and then hence what we're talking about now, all the way through Web 3. So worked for huge companies, FedEx for scale, and then just more recently, I function as a CISO for a blockchain AI company, hence why we're talking.
Now, you ended up in blockchain AI, but what part of your career, having started out in the military, working with other companies, and made you say, hey, this looks really cool? Was it just simply answering an ad in the newspaper or something on the back of a matchbook cover? It said you could drive a long haul truck, or you could go ahead and be a blockchain CISO, or what was it that moved you in this direction?
Yeah, I've yet to see any ads on the back of trucks for Web3 or anything like that. So nothing like that. And I've found throughout my career, and maybe yourself too, the best jobs I've had in my life have been, intros. Somebody looking for something that wasn't advertised, friend of a friend. And that's how this one worked out. Um, I worked with a local company in town for a number of years on just, various work things. And they had an opening for a CISO, or at the time it was a director of security position at a blockchain company. So one thing led to another. The person I worked for at the time, again, was a former military person. So we clicked. And again, I guess I kind of backed into it, but I really enjoy the space. I think there's lots of room for growth and security inside of Web3.
I think there is. So for our listeners who are new to the concept of Web 3.0, could you explain a little bit about how is it different from either Web 1.0 or in Web 2.0? In fact, even maybe go back and say, what's the difference from 1 to 2 and now 2 to 3?
Yeah. So, in your traditional Web 1, basic web server doing an incredibly basic thing. I think if I really dig back into my memory, one of the first web pages was serving up the status of a coffee machine somewhere in England. So again, a super basic website that served an incredibly simple function. Going into like Web 2, you're getting into things like some sort of e-commerce, banking, that sort of thing, buying a car. Into Web 3, there was really a push to decentralize everything, not rely upon traditional infrastructure. So if you run across a Web 3 company that is completely bought into Web 3 and they're not even using any Web 2 technologies, there's a very strong chance they're not running on traditional cloud infrastructure. Everything's decentralized, and you're going to find as we have this conversation, I'll probably say decentralized a lot. And the best way I can describe that, for older folks in the room, myself included, is if you think back to peer-to-peer, if you thought about how that workload was distributed across, thousands of nodes across the planet to, download an MP3 that Metallica didn't like or didn't want you having. The same thing sort of happens in Web3. The workload spread across a bunch of nodes, and those nodes can be as simple as maybe somebody's server farm in their basement, a high-powered desktop. So again, small workload running across a huge set of decentralized nodes across the planet. And then there's some obvious security mechanisms in place that would prevent, somebody from throwing up a rogue node and infecting all that.
Now, do you remember the SETI project years
Yep.
ago? And for those who don't remember that or don't have enough gray in their beards, that was a distributed opportunity to download a screensaver. And while you weren't actually working on your computer, it would take little chunks of data and it would scan through the information that was obtained in the search for extraterrestrial intelligence and try to see if a signal was found somewhere in all this radio telescope information. Now, to my knowledge, it got an awful lot of people signed up for it. I used to run it, I think, back in the 90s, if I remember the dates right. Might have been the thousands. I'd have to look it up. And everything's Googleable these days. But the thing was, I don't think we found anything there. So from this perspective, we say there is a precedent, but that didn't have anything to do with the blockchain. That was just take a workload and split it up into a lot of little pieces. But in that case, all those little pieces were independent. That is to say, much like Bitcoin mining, miners aren't necessarily doing it to cooperate with each other. Miners are basically competing against each other. And so you could take out all but one of the miners and still have processing power working on the core problem. If we take a look at a more traditional IT challenge, I have an app, I have some input, I have some processing, I have some output. Can I chop that up into little pieces, into shards, if you will? And then how do I orchestrate that? So if I push this workload out there and these are cooperating, that somehow I get all the right answers back. I can merge them together. And this is a big, long, complex question, so it's probably going to take 10 minutes to answer. And then what do you do about resiliency? What happens if one of the nodes, somebody pulls the plug on it, but it was doing a core piece of calculation on which something else relied on? Do you duplicate the load? Do you throw in inefficiencies? A whole bunch of stuff out there. And I'm hoping if you get an answer to this, all of a sudden the idea of Web 3.0 clicks for people listening to you.
Yeah. So yeah, definitely lots to unpack there. So kind of going back to my prior answer about mechanisms in place to only allow folks that are supposed to be on that closed node, if you will, that particular blockchain for operating. So oftentimes you'll find that the protocol that they operate on usually operates on proof of stake or proof of work. The easiest one to describe is probably proof of work, which means that when they've got and get the particular package they're supposed to be working on or whatever app they're supposed to be supporting, that node has to perform some sort of basic function. Think of it as a puzzle. So that node has to do some sort of compute. And if they provide the right answer back, they're allowed ingress into that blockchain and they could do whatever they're supposed to be doing. So, and also too, there's another term, throwing lots of terms at you here, but another one's called consensus. So it's effectively voting. So all of the nodes get together and vote and say, okay, yep, the node, the network all looks good. Let's go ahead and process. And then if you find some folks that, either don't solve that puzzle or for whatever reason not voting, they're just not included in that round. Blockchain is very resilient. You said it, I think, again, on the prior question, it can operate at a very small percentage of available nodes. So as long as you have a working copy of that blockchain, a working copy of the voting and the proof of stake or proof of work have been completed satisfactorily, that transaction, that app, whatever it is, will continue to work, continue to function.
So that's sort of interesting. So it sounds like instead of taking a task and breaking it up into little pieces, it's almost like DNA, where every cell in your body has the code, if you will, to run any other cell in the body. It's just that you're only going to use whatever you need right now. Hey, I'm doing this function. But is that a good analogy in that you kind of push everything out to everybody and then you say, hey, you work on this stuff, but if somebody goes down, well, okay, go pick up that load too.
I think it's a decent analogy. I guess I don't think I've ever heard anybody describe blockchain as DNA before, but I don't see anything wrong with it. I think it works. You can push workload to larger nodes that maybe have more compute power, or smaller ones that can solve some very basic in and out sort of tasks, like executing a quick smart contract.
Mhm.
So I guess I should probably describe what smart
Yeah, so
contract
let's
is.
jump into blockchain. So we'll go
Sure.
ahead and we'll start defining a little bit more. It's kind of a little bit like Duolingo, where all of a sudden you get served up words you never heard before, and if you happen to guess right, but ding, you're good. Otherwise, it gives you some remedial. So let's just start out with blockchain. Most of us have heard of it, probably get a good feel for what it is, but not sure any one of us could explain it to our grandmother, for example. So how would you define blockchain and explain it?
Yeah, I try to come up with an answer to that my parents will understand. So for all effective purposes, I like to call it a ledger, a notebook, a public um, record of things that are happening. I think we said it at the onset of the call, but if not, when something happens on chain, it's there. You can't delete it. You can't erase it. You can attempt to cover it up and muddy it, but that's what's pretty neat about blockchain, Web3. Everything's open, everything's transparent. When you buy something or purchase some tokens or coins, that's recorded. And if you know someone's address, you can look it up. So you're not really hiding anything. There's ways to mask it, but it's always out there. So again, the best way I can describe it is a very open, very public notebook that you can never erase out of.
So the CIA integrity, that's a big, big strong suit here for a blockchain.
100%.
So we're writing in ink, we're not writing in pencil. And once it's recorded in the book that is bound, you can't get it out.
Yep, agreed. It's not going anywhere. So, hopefully the stuff you're putting on chain, it's stuff that you want out there for forever. Because, like the old adage goes, once it's on the internet, it's not going anywhere.
Yeah, and so what blockchain does, now the first blockchain out there was Bitcoin, and that was a result of a 2008 paper by Satoshi Nakamoto, and we'll get into an entirely different discussion about the identity of that, which we'll avoid for now. Just say that, boom, it exists. And in January of 2009, the Bitcoin blockchain began. And essentially what it was is that for each block or set of transactions that were submitted, one would compute a hash function, and the hash function would require a certain difficulty factor. Now, if you're familiar with a hash, you take something like a 256-bit hash. What the idea of a good hash function is that it should be it's unique, that is to say, it's deterministic to your input. But if you change one bit of the input, you should change about half of the bits of the output. So it's not like a radio where you're almost right and boom, I got it. It's like a lottery that either it pays a jackpot or it pays nothing. You either have to be exactly right, but if you're one off in the lottery, it pays nothing. So from that perspective, how do you get there? The early blockchain was a pretty easy calculation. Of those 256 bits, what you would do is you would calculate a hash. Well, the hash is a bunch of ones and zeros, and they say, well, here's your difficulty factor. You got to start with 32 binary zeros. Okay, about 4 billion. Well, that means on average, I'll have to try about half of that, about 2 billion tries. Well, how do I perturb that value? I can put in a nonce, a number used once, and I alter that, and I just throw that in there and calculate it again, and throw that in there and calculate it again. Eventually, after, on average, about 2 billion tries, I'll yell, bingo, I have got a result that gives me those 32 zeros. Now, if there's any other miners out there, they're all going to vote on that, as you'd said, and they say, yeah, Gmark got it. Okay, let's go on to the next one because more transactions have been pouring in. Well, the more miners that want to play, the harder the problem gets. It auto adjusts. And so you go from 32 to 33. So now we're up to 80 some odd zeros, where the amount of power required to run the Bitcoin blockchain, just the Bitcoin blockchain, succeeded that of countries like Austria, the entire nation. Everybody turning on their light and turning off the light and everything else for the whole year is being consumed by this thing, by Bitcoin. So with that as a little bit of a background, you can find out then is the reason it's unalterable is that if I wanted to change something in the past, and put it onto the blockchain. The problem is that every subsequent block has, as part of its input, the cryptographic hash of the one above it. And although you might have one that begins with 32 zeros, the rest of it isn't the same. So you're going to have to pre-compute the second hash, then the third, then the fourth, until you catch up till now. Well, this took all the computers in all the world trying to go ahead and work this problem to come up with a block every 10 minutes. And now you're a day behind. You'll never catch up. There's not enough computing power on the planet to catch up. And as a result, your blockchain becomes unalterable. And that has been perceived as one of the real values of that. So with that as a baseline, I didn't see object to anything. I'm sorry if I went into teaching mode, but it's kind of what I do, is Web 3.0. Other than the fact that I could record a transaction and it doesn't get altered, why do I want to do a Web 3.0 in that type of an environment? Why don't I just go to AWS and host a virtual machine? What's the business benefit here?
Oh, I guess I'd say a lot. It's the typical IT answer. It depends, and it depends on a couple of things. You mentioned, the underlying current of Web3, as folks try to get into it, try to understand it, they think a lot of it has to do with the criminal element, the dark web and that sort of thing. So that's something that Web3 is definitely trying to get away from. But back to your original question is, why bother getting into Web3? I guess for a lot of startups, quite frankly, unless they've got angel investors, they don't have a lot of money. So you can get a Web3 startup off the ground pretty quickly. If you've got a very lightweight application, something that's doing a very basic function, doesn't require a ton of compute, you can get 50 of your best friends up and running those nodes and doing whatever it is that application you're trying to do. And you don't have to give AWS, Azure, the big cloud providers out there a ton of cash. So for me, I think it's flexibility. It's ease of use and getting to the market quickly with an application that you can start to make money back.
Now, when you talk about applications, we're probably not talking about something like QuickBooks or the like, but rather something that is, you had alluded to earlier, which got us down this track, the term smart contract. So what is a smart contract, and then how does that enable trust in a decentralized system?
Yeah, for me, the example I like to use with a smart contract is, don't get hung up on the name. It's just a piece of code, usually some sort of like a self-executing program. And the real world example I can give from that is something that happens that doesn't require human interaction. And the most basic example I can give is if you walk up to a Coke machine and you want to, select whatever it is. So you put the coin in, or in this case, you're probably swiping your card. You're, picking a Coke or two. The machine does its thing. Hopefully it spits out the Coke. You grab it. You make sure that if you're using a credit card, you're making sure that transaction's done. You hit that cancel button a bunch of times and it's done. The whole process is complete. You got your Coke in your hand, you're refreshed. That's a good way to show an example of a smart contract. So again, it's something that happens. It doesn't require any human interaction. It's typically all automated.
Right. And some smart contracts can be ones such as you have inputs coming from other sources. So current blockchains like Ethereum allow you to go ahead and run smart contracts where you use some programming language, Solidity, and said, hey, here's my contract. It says, I want to buy something from Aaron, but I don't trust the guy. And he's going to sell it to me, but he doesn't trust me. So we could set it up so that I could put my Ether in escrow. And when FedEx delivers my package from him, that acknowledgement that FedEx has dropped it off, which he can't control and I can't control, is read as an input to the contract to say, complete the transaction, send him the money. And if that doesn't appear in a certain period of time, send the money back. Now I've been able to use this smart contract as a trusted escrow agent, so to speak, to ensure that some transaction goes through. And so one of the things I used to describe blockchain years ago as federated mistrust, which is the complete opposite of what people talk about when they want to enable trust. But really, I federated the ability to transact between two parties that may have never met each other before. They have no prior relationship, and yet they can come up with a way to create some sort of a trusted correspondence. So that's the kind of a cool thing you can do. And if you imagine that as a basis for being able to create applications, that's pretty powerful. Now, the other thing you'd mentioned earlier is the concept of proof of stake, proof of work. And you mentioned about proof of work is doing a certain amount of crunching away. And I liken it to your high school teacher who used to say, you have to do these homework problems in math and turn in tomorrow problems 1, 2, 3, 5, 7A, 7B, or you can't get an A in the course. Well, I may understand the material and I don't need to do the homework to get it. But if I turn it in, I haven't done the proof of work and my professor's not going to give me an A. But what's this proof of stake thing that we hear about, and why is that different? Is it any better or worse, or what?
Yeah, a little bit different than proof of work. It's not the traditional puzzle challenge. It's not solving a bit of code. It's typically adding something new, like a new block or something to that code that they're processing. So they're going to take that, lock it up, chew on it. When they roll through it, their new piece of code or whatever additions required gets added into it and sent back up the chain. So they have to do something, make an addition to, or generate something that's completely different to work and I guess function and operate that particular transaction or complete with that input or output, whatever it was they were asked.
Okay, so proof of stake in something like a blockchain like EOS, for example. I'm not sure if you're familiar with that chain. I don't want to spring something on you if you're not, but they use a proof of stake. So if I say, okay, fine, I've got 100 users out here, and a couple of them are really big users. They have a lot of coins, a lot of tokens, if you will. And somebody submits a transaction. Instead of doing the Bitcoin thing, which is let's go ahead and melt the polar ice caps, I still think that historians will record that the true cause of global warming in the early 21st century was the mining of cryptocurrency, but I digress. But now in the proof of stake, what's happening a little bit differently here when you got these big players and these little players and a transaction comes up?
Well, it goes back to locking up things. So locking up things usually is tokens or coin. And in this case, you mix it all together and you're locking up a combination of, monies, transactions, and then whatever section of work it is they're working on. So and proof of stake also has to do with kind of randomly being selected to add different things to that. So you're not going to get picked every time.
Mhm.
And your odds of, being selected has to do with how many you put in. Say, I want to put X amount of coins to stake. Okay. If you offer up 10,000, there's a higher chance you're probably going to be selected to do that. So,
And if you do that, what you're basically doing is you're putting your reputation on the line. You said, hey, I will put in 10,000 coins to assert that this is true. And you figure like, well, man, that guy's put a lot of his money up on the table here. He's probably pretty serious about it because he wouldn't screw around and back something that he thought was wrong. Because although they don't take the coins away from you, they will basically destroy your reputation, at which point they're going to like, yeah, let's never pick this guy again because he made a false assertion. And the other complaint about proof of stake was, well, a little bit of the rich get richer and the poor get poorer, much like today in finance. If you've got $10 million and you stick it into investment accounts, but you got to pay your living expenses, well, guess what? Your investment accounts are going to continue to do well. If you have $100,000 and you got to go ahead and spend 70 or 80 or 90 to pay all your bills, yeah, you're going to make money, even if you made the exact same investments as those bigger people, but it's going to start to split and go in different directions because you have different start points. And so there's no real correct answer here. It's almost a matter of religion, what it comes down there in terms of proof of stake, proof of work. But they both involve something called tokens, what we talked about, either like a Bitcoin or Ether or whatever it happens to be. But what's the role of tokens in a Web 3.0 ecosystem? And how would they differ from, let's say, a traditional digital asset where I can go to Gemini and say, hey, let me put some money on the table. I want to walk away with a Bitcoin wallet with some coin in it.
yeah. So, it's going to vary, and it's going to vary based upon, whatever company or asset or organization you're buying a token from. But a lot of them work some sort of asset back into the token. So you own a, microtransaction or a fraction of that company, a small stake. So you've got a general reason why you're buying that token. You want to invest in said company. So, you're effectively a small time owner in that company. And on the flip side too, they do function as a regular, Bitcoin or Ethereum or whatever kind of currency you're working with. So not not a NFT per se. That fad is thankfully gone by the wayside, but it's a small ownership stake. And on the flip side, most people associate it with some sort of value, some sort of monetary value.
Right. Now, you mentioned in passing NFT. So for those who are not familiar with a non-fungible transaction, what is an NFT or non-fungible token? What's an NFT?
Some sort of rare, I put in quotes, rare digital image. The ones that a lot of people know. You heard of NFT, or if you can, pronounce that god awful acronym that you just mentioned. It's the Bored Apes. So there was a series that came out, probably about 3 years ago, and it was fairly creative paintings of apes, literal apes doing some sort of funny thing, betting on a poker game, smoking a cigar, some sort of avant-garde comic. So it was the way it was rare is maybe only one or two of those apes was produced. If you had it, the what it was worth was straight market value, and it was kept somewhere. And again, everything we're talking about here is digital. You can't grab it, you can't put it in your pocket. So um, you're putting it in some sort of digital enclosure. And the way I best can describe a digital enclosure is think of it as a wallet, quite literally a digital wallet, where you've got an address, and let's say your address is 10,000. Obviously, that's not it. You take and buy one of these rare NFTs, back to the ape example, and then you can put it in your wallet. And hopefully you put it there, you forget about it, and you come back in, 3 or 4 or 5 years, and it's worth twice that. Well, not so much. That market's kind of evaporated. So the NFT, I think, has gone kind of by the wayside. You'll still see them a little bit. The piece that I kind of miss is I try to go to concerts every now and again. And I tend to keep, much to my wife's chagrins, like ticket stubs.
Mhm.
It's cool to see it. It's cool to have a memory. You don't find printed tickets anymore. So oftentimes now, when you go and buy a concert ticket to a Ticketmaster that's way overpriced, uh, they'll give you a minted NFT to show that you went to this concert, and it's not worth anything. It's worth a
Mhm.
memory to you, more that kind of value, so that you could take and put that into a wallet. So kind of a long-winded explanation, but NFTs, I think, kind of a passing fad. Um, are the Bored Apes worth as much anymore? I don't know. I don't think so.
Yeah,
I
in
know the bottom
2021, when
dropped
they
out
came
quite a
out,
bit.
they peaked at about $4 billion in quote unquote value, but it's
Yeah.
basically the value was defined in what they were worth in Ether. I
Mhm.
remember when Ether first came out, I think it was $1. You buy as many as you wanted for $1. And I think when I got in at like $7. And then it went to 50 and like, man, wow, I got 7x and got out. Of course, then it went up into the thousands. So like everybody else, here I am still working instead of
Mhm.
retiring on my crypto millions because I got rid of my crypto hundreds or crypto, tens instead of crypto at a higher end. That's okay. But the thing is, what we find then is that some of these early experiments were necessary to try to figure out what would work and what didn't work. And so what we find then is that the real challenge today between Bored Apes, doing drug deals, trying to go in Silk Road, trying to come up with all these other interesting concepts are legitimate business cases for Web 3.0. And so, what industries do you see that could be disrupted by Web 3.0? And any example that you might have either worked on or studied that we could explain to our viewers?
Well, we've already talked about the biggest one, crypto. Crypto is by far probably the biggest use case for blockchain. Pretty much everybody knows about that. Even if you're not familiar with Bored Apes, NFTs, and all the crazy acronyms we've thrown at you over the last 30 minutes, you probably know what blockchain is. So moving that one aside, the other use cases that I've seen, some sort of finance, decentralized finance. I see a lot of banks, a lot of big name banks have embraced crypto. You'll see some countries will actually put a lot of faith and a lot of government stock into whatever crypto or sponsor a particular bank. So that's a big one. Um, Microtransactions. I've got kids that are way into video games, and they're always asking for more money to buy skin or an add-on pack or of the like. You can, I guess, provide the mechanism or medium for that to happen. You can have a microtransaction in a game that would go over blockchain and happen instantly. There's not a lot of, like if you're accessing a typical credit card network, you're the person facilitating the transaction and you often pay to use that network. These microtransactions are so small, it doesn't require a lot of compute for it to happen. It makes a lot of sense to use it for that. So that's another use case. I see a lot in, we already kind of mentioned finance, but just typical commerce. You want to buy something point to point, something simple. It doesn't require, maybe a lot of negotiation. It gets back to what we were talking about earlier with smart contracts. You can just make it happen. It doesn't require a lot of human interaction for it to function. So those are some big ones. A lot of traditional business to business things. I see companies embracing it. So it's really up to your imagination. Whatever you can find a way to use that blockchain, and if you're not looking to hide anything, again, everything being public and open, it's a great mechanism for simple business to happen.
And there are, of course, the public blockchains and private blockchains. So several years ago, I had a client hire me to go out and build out the specs for an app on IBM's Hyperledger Fabric framework. And the idea with the Hyperledger Fabric is that we could create a custom blockchain. It's not Bitcoin. It doesn't require somebody running a gigantic water mill in China powering all those machines. In fact, the validation is asserted by a cryptographic signature. Because it's a private blockchain, everybody in there is, trusted. And so if I have a government situation and I want to say, for example, I'm going to post everything that the government spends money on, how's that for transparency? And oh, by the way, anytime you pull money out of the government account to write a check or pay a bill, that account has a tool, because it's got an app that has the private key that asserts that this particular transaction is valid. And here is the public key that anybody could download and take a look at it. And oh, by the way, the balance is always available to the public. You can see how much is in the bank, and very quickly you can add up all the things that are paid, all the deposits in, and you can balance the government's checkbook. Imagine if our government gave us that level of transparency with our tax dollars. That could be monumental, and it would, of course, scare the daylights out of anybody who's trying to steal money from the government or trying to pull a little fast one. And that might have been over the years where I've had some difficulty getting it, because pure transparency could be a little bit frightening. How about another business in terms of Web 3.0 and some of the blockchain? And we discussed this in the pre-call about, let's say, go back to banking. I have all my transactions. Now, typically what happens is that if I have a database, I'm trying to keep track of this person sent money to here, this deposit, that place. Somebody comes in there and they blow away my database. They've damaged it, they've destroyed it or whatever. How do I reconstitute? How do I know to whom do I owe money and things like that? Well, banks are pretty robust because they're subject to regulation. So they've got a pretty good IT security department, lots of people doing it. Now, you had mentioned crypto, and a lot of these crypto businesses that are coming along, they don't have 100 people. They probably don't even have 10 people that are focused on IT security. And as a result, if you're a smart crook, where do you go? Well, like Willie Sutton said, why do you rob banks? Because that's where the money is. Well, why do you want to rob crypto? Because that's where the money is, and that's not where the cops are. That's not where the smart defenders are, because they don't have enough smart defenders there. So from that perspective, if we take a look at to say, what if you could put all of your ledger up onto a blockchain? If somebody blew you away, you've got an immutable record. Oops, your files are encrypted. So what? There's another copy out there. So then what we find out then is that we have the C, I, and A. We already talked about I, the integrity is there, but now availability, because you can't drop a bomb on the blockchain. You can't blow up Bitcoin. You could blow up a data center, but you can't blow up Bitcoin because it's decentralized. It's running all over the place. So from that perspective, imagine the robustness of a security backup solution that could never, ever be attacked or destroyed. That's another interesting business case. How about healthcare or legal? Anything that you can think of in terms of Web 3.0 where it would apply well?
Yeah, I do see a little of both. The healthcare is kind of an interesting one because you've got the HIPAA implications. So if you could find a way to potentially maybe sterilize the data a little bit before it goes on chain, just find a way that you're not identifying, my health records, your health records. Maybe if it's just the transactions, that would obviously work because it's a typical e-commerce transaction we talked about. a lot throughout the call. So that would be, I think, maybe a little more tricky. I do know companies that are operating Web3 healthcare companies on chain, so it's feasible for sure. Legal, I would say so because a lot of the legal things that you're referencing in lawsuits and judgments, the typical case law, it's published, it's known. It doesn't change all that much year to year. So it might be a good way to go back to what you were saying about backups. You could very easily, dump your entire state of Florida or pick a state or US government um, case law into maybe a public or even a private blockchain and use it as a quick way to reference things. So, yeah, maybe not as sexy as some of the other things we've talked about, but I think very doable.
Yeah, and I could see going into contract law. So, for example, in Florida, if you want to buy a house, they give you something called a FAR. It's a Florida Association of Real Estate Board of Realtors. I could look it up. But the idea is that instead of, for example, hey, I need an attorney to write up a contract, this is a standard contract. The language is fixed. And as a result, you fill in the block and you fill in the block. And if you want to change a term, you've got to sign it. And it's pretty obvious. You can't go ahead and add a weasel word like changing yes to a no or a do to a don't, and then hope that the other person doesn't notice it. So why do I mention that in terms of blockchain? So if I have, for example, the state of Florida says we approve these following 100 clauses that could be used in legal contracts. And here's the plain language meaning of this stuff. And stick it up there on the blockchain. Now, somebody wants to argue what's in your contract and they say, well, it doesn't mean what it does. Well, let's go back. Does this paragraph match exactly what's in the blockchain? Why, yes, it does. And what does the government say? This is exactly what it means. There is no room for arguing. I'm sorry, you can't go to court over that because it's a laydown. The judge just simply dismiss you with prejudice right away. They said, you're an idiot. It's exactly the language that has been approved as compared to, oh, wow, somebody came up with something and can we try to interpret it? So lots of ideas. How about supply chain? I mean, supply chain attacks have been a concern that we've talked about, and more so in recent years. They had Cassie Crossley on here last year talking about her book on supply chain security. Can you think of how Web 3.0 could transform supply chain and maybe some examples of that?
Maybe if you've got a situation where you're dealing with maybe an older supply chain, one that's massive and it maybe takes a long time to fulfill an order, look something up. You potentially, if you took that and do the work is streamline it, make it as quick and agile as possible, then put it into a blockchain. I think you're looking at a situation where you're probably decreasing transaction speeds, getting stuff to customers quicker, providing quicker lookups. So probably speed to market, getting things done a lot quicker than having to rely on a traditional lookup or even potentially calling somebody to see if they've got widget X, Y, and Z in stock.
Right. And then that also screams for the case of a private type of a blockchain like IBM Hyperledger Fabric. And in fact, if you go to the IBM site, at least they did several years ago when they introduced that, but the supply chain was exactly the case that they offered, kind of an early Web 3.0 idea to say, hey, look, I've got stuff for sale and I got someone who wants to buy it. And what I can do is I can make a pricing such that this person has permission to see my wholesaling price because he's a wholesaler, but this retail customer can't see the wholesale price. If they want to buy directly from me retail, they can, but I'm not going to compete with my downstream. I'm not going to undercut them. And so as a result, I can set up all these things based upon trust, identity, and then my whole supply chain. Then when somebody wants to place an order, you say, my computer is talking to your computer. I'm not relying on a virtual web server or something in the cloud that may or may not go down. This thing is all being recorded on a blockchain. Everybody gets a copy of the blockchain, so there's no argument as to exactly what happened. Oh, you said this. Well, I said that. Nope, it's right there. And as a result, your dispute should go down to zero. Your ability to automatically manage inventory and things like that could work out. So this Web 3.0, which at first when you look at it, you say, well, is that kind of like putting a website up onto the blockchain? That doesn't make sense. No, this is not the Web 1.0 where you have the hamster dance or, this site has been viewed 1,273 times. If you remember the old black background and the words and then the little blinking thing at the bottom, the Web 1 or the Web 2, where you actually had some functionality where I could put money in my bank account, pay my bills, things such as that. Now at Web3, we're looking at a different transition. What do you see beyond that? I mean, what's the future of Web3? Is there a Web4 on the horizon, or have we reached our apex of thinking for security? So,
Yeah, I definitely don't think we've reached the apex. I'm surprised it took us, 40 minutes to get to this point in the conversation. We haven't mentioned AI. So, there'll be some sort of AI layer to this where,
mhm.
things happen a little quicker. Maybe a lot of the smart contracts that are being generated just happen, to use some bad English, automagically. So I think there is a web, web 4, web 5 eventually. What it looks like is anybody's guess, but I think AI is going to have a huge part of it. A lot of the things that is maybe done right now manually are probably going to happen a lot quicker, and aren't going to require a lot of human intervention rather, because AI have already done it, already put it out there on chain, and humans are off solving harder things that maybe AI can help them out be a little more efficient on. So again, a little bit of a ramble answer, but I think AI has to do and will play a big part in the next iteration of the web.
Very good insight. Okay, open mic for the next couple of minutes before we wrap up the show. Anything else that I didn't cover, or you want to make sure that people understand and hear from you?
Yeah, I think a big part of Web3, if you want to embrace it or look at blockchain or you're just interested in it, don't let the dark web scare you. It's not the movies. It's not some terrible movies that depict hackers. It's a pretty safe place to play. Don't get fooled. Would be something I think is worth saying. There's a huge element of people that are trying to fool you, no different than a traditional phishing attack or something in a Web 2 style attack. The big things I see where people are losing their money consistently all day, every day in Web 3 is getting fooled into entering their wallet credentials into a fake website. So that's still a big problem. Probably don't swap crypto coins with some random person on the internet. That's going to lead to disaster. And then if you're getting something where it says, hey, check out your password's been compromised on your Coinbase account, maybe verify about 6 times before you go ahead and do that, because it happens. I've watched it happen to very smart people. So
I got something a couple of weeks ago saying, hey, your account, I forget who it was, whether Gemini or somebody out there, somebody I never even think I even had coins in there. But it said, oh, yeah, they under a lawsuit, they have to go ahead and they can no longer hold coins. You need to transfer it over to this. So here's how to set it up. It's all fact. And oh, by the way, here is your private key. So make sure you put it in a safe place. And I think, like, why would you put a private key in an email? And it's like, up to that point, you had me going. And then they went ahead and they checked up and there was no lawsuit against them. There was no things like that. But the plausibility seemed to make sense till you get to that. Really? Because what's happening? That's their wallet, and thank you very much. You put it in there, and they'll take it right back out.
Yeah, these scams are a lot more elegant. Gone are the days of the very poorly written, awful grammar, misspelled Nigerian prince 411 type messages. You have to look at things. If you and I give something pause and we're looking into it all the way to the end where you just mentioned it, you got to imagine somebody who's not as well versed in security, and it's not something they do all day, every day. That's why people are still getting taken. So, how's that saying go? Trust but verify. So
Yeah.
definitely use that.
So with your insights in Web 3.0 and security, if somebody want to get in touch with you, what's the best way to do that? If they had some follow-up questions for you.
Probably LinkedIn. I don't do much social media. LinkedIn's about the biggest thing that I do. It's very easy to find me on LinkedIn. There's only one Aaron Markell out there. So there's a picture of my nice, shiny, bright face with a beard that doesn't have as much gray in it. So that's about the best way to get a hold of me.
All right, sounds good. So Aaron Markell, Markell on LinkedIn would work out well. Well, thank you very much, Aaron, for being on our show, and thank you for everybody else for watching or listening to CISO Tradecraft. We hope we're giving you the information you need to improve your cybersecurity career. If you like the show, go ahead and give us a plus or a like or a 5-star or whatever it is at the platform you're on. And also, if you're not sharing this with your contemporaries, do so. Let everybody else know where you're getting your insights, because you can help other people in their careers as well. One of the great things that we have is the ability to act as mentors to our coworkers, to our team that's working their way up, and we make CISO Tradecraft available as a free resource, so you'll be able to do that. So thank you again for your time. This is your host, G. Mark Hardy. Aaron, again, thank you for being part of the show. And to everybody out there, until next time, stay safe out there.